Here's a question. How many elements of order 2 in A8 have the disjoint cycle form that they are a product of 4 disjoint cycles? Which in general you could write like this, where A1, A2, A3, etc. These each represent unique numbers from the set of numbers from 1 to 8. These are unique numbers from the set 1 through 8. That is what permutations in S8 permute those 8 objects. These A's are each unique, is what I'm trying to say. There's no repeats. They're disjoint cycles. This would not be all the elements of order 2 in A8, because you could also consider elements that are products of two disjoint 2 cycles instead of 4 disjoint 2 cycles, for example. A8 is the alternating group. That consists of even permutations instead of odd permutations. We have an even number of 2 cycles here. A8 is a subgroup of S8. Again, A8 would contain only even permutations. S8 contains both even and odd permutations. So this was one of your homework problems, and yeah, the answer was in the back of the book, but I did ask for explanation. Haven't graded it yet. How do you solve it? How do you think about it? How would you give explanation? I'm probably just going to verbally give explanation instead of just writing stuff down in words. I'll write down an equation, but how to think about this? You think about it in terms of counting principles from discrete math and prob and stats, combinations and permutations. In fact, it's the fundamental counting principle that the number of ways of doing, 2 or 3 or more tasks one at a time, when you got so many choices for the first task and so many choices for the second task and so many choices for the third, etc., is to multiply the number of tasks, of ways of doing each task. We've got 8 numbers here to put in these spots A1 through A8. Initially, you could say, well, I've got 8 choices for A1, 7 choices for A2 because I've already used 1 choice, 6 choices for A3, 5 choices for A4, 4 choices for A5, 3 for A6, 2 for A7, and 1 for A8. So the initial thought is, because of that, maybe the answer is 8 factorial. But that can't be right, because we know S8 itself, the order of S8, the order of S8 is 8 factorial. How big is 8 factorial? I'm forgetting. It's in the ballpark of maybe 10,000 or something. 8 factorial, where's my math mode? 40,000. 40,320 is what 8 factorial is. That's how many permutations are in the symmetric group S8. They're not going to all be of this form, so this can't be the answer. Then you remember some things that we've said. When you write a permutation like this, it's not unique. A1, A2 is the same as A2, A1. And that's the case for each one of these 4 2 cycles. So one thing I have to do to account for that is I'm going to divide by 2 times 2 times 2 times 2, because there's 2 ways of writing each one of those. But before you celebrate, we're still not quite done, because disjoint cycles commute, and also because Since each of these cycles is a 2 cycle, they're indistinguishable from each other. We could rearrange the order and get the exact same permutation. As an example, 1, 3, 2, 8, 4, 5, what's left? 6, 7 is the same as 2, 8, 6, 7, 1, 3, 4, 5. And there's more ways I could write it. In fact, for any one of these given product of 4 2 cycles, how many ways could I order those things and get the exact same permutation? 4 factorial, 24. So you get to divide by that as well. And yes, that's 24. So the final answer here is to take the 40,320, the 8 factorial, 2 to the 4th is 16, divide by 16, also divide by 4 factorial, divide by 24. There are 105 elements of order 2 in A8 that have this disjoint cycle form. They are order 2, right? Because being disjoint cycles, the order is the LCM of the lengths, but the LCM of 2, 2, 2, and 2 is 2. But yeah, they're not the only elements of order 2 in A8. Other elements are 2 products of 2 2 cycles. Or I should say products of 2 2 cycles. You were not asked for this on the homework, but I could ask how many elements of order 2 in A8 have this form. Maybe I'd put that in the test. Again, I verbally gave some explanation. Perhaps I wouldn't have you fully explained it on the test either, just write out things like this, but I think it's good to hear an explanation. Once again, you've got 8 choices for A1, 7 for A2, 6 for A3, 5 for A4. But for each one of those 2 cycles, there's 2 ways of writing it. And also, either order can be, these things can be written in either order. We also need to divide by 2 factorial, which is, of course, is 2 as well. 2 times 2 is 2 times 2 times 2 is 8. Those cancel with the 8. The answer ends up being 7 times 6 times 5. Can I do that in my head? 6 times 5 is 30 times 7 is 210. There's 210 permutations in A8 that can be written in this form as a product of 2 disjoint 2 cycles. They would have order 2 as well. Are there any other elements of A8 that have order 2? A single 2 cycle is not an A8 because it would be an odd permutation. 3 of them would also not be an A8 because it would be an odd permutation. A8, the alternating group on 8 objects, only consists of even permutations that can be written as an even number of 2 cycles. You can't have 6 of these because you only have 8 numbers to choose from. Yes, you could write 6 2 cycles in a row, but they would not all be disjoint and still be in A8. You could simplify them to one of these forms. It seems that these are the only kinds of elements of order 2 where the LCM of the length of the cycles, of the disjoint cycles, is going to be 2. So the sum of these two, 315, would be the number of elements of order 2 in A8. A8 would have 8 factorial divided by 2 elements. 8 factorial divided by 2, 40,320 divided by 2, 20,160 elements total.